what the sign of a number was.
Is there a branch of calculus based on creating polynomials that look like pretty pictures?
No, I may have invented that branch with the pre-calculus art project.
Wait, how did you do it?
It was stupid parking project.
How did I do it for calculators? Every math book had, every math book had tables in the back. Like 15 pages of tables. And they had the sine, cosine, tangents, and logarithms. Base 10 and base E for like 0 to...
Wait, you weren't allowed to use one.
Hundreds. Depends on the... Yeah, you had to use the table on the test. You had a 4-function calculator because you couldn't memorize. I mean, you do problems where it's like, what's the sine of 47 degrees would be part of the solution. So you go to the table, you look up the 47 degrees, you write the decimal in your work, and you punch it into your little 4-function calculator. And we didn't even, some of us didn't, at first we didn't even have 4-function calculators. So you plugged in a little decimal and you did it all by hand.
I'm sorry your life is so miserable.
It was. I walked uphill through the snow both ways, barefoot, to take tests without a calculator.
Barefoot.
Yes.
Did you ever get your knuckles hit with a ruler?
I did, actually.
My dad did that to me when I was little.
Okay. All right, now there's a couple other things about these polynomials. Let's do an example here. Okay, I'm going to add a new idea into this example. F of x equals x plus 5, x minus 3, x plus 1 squared. That squared changes things a little bit. But first off, in this form, where does this thing hit the x-axis?
-5, +3, -1.
Excellent. -5, do a rough sketch of this, +3, and -1. Okay, if I multiplied all of these together, what would my first term be?
Why -1?
Switch the sign.
Cube.
Nope. This x squared means that x is going to get multiplied by itself. Think about it. I could write this out. Yeah, I could write this out and use x plus 5, x minus 3, x plus 1 times x plus 1 again, right?
So it'd be x to the 4th.
Yeah, so it'd be x to the 4th. That's what, and then it's going to have a lot of stuff in between that we're not going to worry about yet. And then what would it end on? It's not really vital to the problem. I just want to see. What would it end on?
-15.
Yeah, it would end on -15. We're not going to worry too much about that. Since it's x to the 4th, what's its end behavior?
Positive.
Positive what? What's its end behavior? Is it touchdown? Is it a ballerina? This is a touchdown. It's an even exponent, so it looks like that. So that means from the farthest x-intercept on the left, this will go up. From the farthest x-intercept on the right, this will go up. Now, there was an idea in here called multiplicity. And the multiplicity of a factor is the power the factor is raised to. So this factor has a multiplicity of 1, this one has a multiplicity of 1, this one has a multiplicity of 2. Odd multiplicity crosses the x-axis. Odd multiplicity crosses the x-axis. So because x plus 5 is to the first power, you know this function goes through the x-axis at -5. Because x minus 3 is to the first power, you know that this function crosses the x-axis at +3. Even multiplicity turns around after touching the x-axis. So here at x plus 1, this function must do something like this. Now, do you remember that the only way to find...
What?
Okay.
Oh, never mind.
If the exponent on the factor is 1, and it crosses through, if the exponent on the factor is 2 or any other even number, it turns around. Okay? One way to remember that, well, actually I'm not giving that hint right now. Not a lot of time on it. Do you guys remember we also used our calculator to find the minimum and maximum points on these?
I I vaguely remember that.
Vaguely remember that. Okay.
So you use
Second
2 points between them.
calc, min, left bound, right bound. That sound at all familiar?
Mm-hmm.
Where you had to, you hit second calc, you hit minimum, if you're looking at one of these, and you had to tell the calculator to go between this point and this point to find the minimum. And we used our calculators to graph some of these. Okay? Combine this with the factoring we were just doing. Remember, the last thing on the test was how to break down a polynomial into factor form. One completely fair big problem on this test, we'll go over this more tomorrow, would be if I handed you something that was like this all multiplied out, you had to use synthetic division to break it down to something like this. Then you had to graph it correctly, knowing the end behavior and the intersection points, and then you had to find the turnaround points using your calculators. Does that make sense? Okay. So I'll end on that note, and I will try and find the test on this and get it posted online. And I'll get what's posted. I'll get the stuff posted from yesterday too. All right. The bells are working, so chill for a minute. I'm going to stop here. Yeah, come on up here.